Good afternoon, students. Professor Lewis here for Micro and Macroeconomics. This is a tutorial for both of y'all. Both the micro and the macro students will be needing this. We're going to be talking about supply, demand, and equilibrium today. We're going to be defining what they are, and we're going to be working on mathematical models for them. And then additionally, for the micro students only, that's the very last few minutes, I'll talk about the price elasticity of demand coefficients. So I'm going to go to screen sharing. We're going to start talking with a little bit of the PowerPoints first, and then we're going to go forward from there. So give me just a second, screen share here, and then boom. And then share. And there's that tunnel effect. Okay, students here, let's talk about some definitions first of all. Markets are institutions that bring together buyers and sellers. There's two sides to the market. You have the consumers or end users, and you have those that produce or supply the product or the resources or whatnot. And so demand is the schedule. Schedule means a relationship between two variables. All else equal, that shows various quantities of a particular good or a service that consumers are both willing and able to buy and consume, or a set of prices that could be charged during a given period of time. We call that demand. In other words, it's the relationship between the price charged for a product and the quantity demanded of that product by the consumers, the end users. Now let's talk about this graph here. This is the first quadrant of the Cartesian plane, but notice we don't use X or Y here. Those are not economic symbols for market theory. The symbols are a capital P for price, a capital Q for quantity, and a capital D for demand. The vertical axis is a dollar sign because price, along with costs and revenues and profits, among other things, are measured in dollars and cents. And all of those variables have a relationship with quantity, which is the letter Q, and is measured in units. Since we're in the US, we're measuring price and costs and revenues and everything in dollars and cents, and quantity is measured in units. We have an origin, $0 and cents for price, 0 units for quantity bought or supplied or whatever. But the thing is, the demand curve, as we call it here, is this straight line. You'll notice it has a negative slope. Now somebody will say, that ain't a curve, that's a line. A line is technically a curve. It just has no eccentricity or bend to it. Booyah! Anywho, the fact that the curve has a negative slope is indicative of something that we call the law of demand. And I want to emphasize, we're dealing with consumable goods and services like gasoline, like food, like clothing. Things that tend to wear out, that have an expiry date, that go bad, that become no longer useful with age. We're not talking about investment type products like stock whose prices could go up or go down, or real estate whose prices may go up over time. We're not talking about those kind of things. We're talking specifically about consumable goods and services that have a finite lifespan that wear out. Now the thing is here, the demand curve is a negative slope, meaning as the price charged gets higher, people buy less, or as the price charged gets lower, people buy more. That's basically a little principle called the law of demand, which means there exists an inverse or a negative relationship between the price charged for a product and the quantity demanded of that product. Class, that's just common sense. If the price of gas goes down, you buy more gas and you drive around more. If the price of gas goes up, you don't buy as much. You try to limit your driving. That's also the law of demand. Now, demand is only half the market. This is only a market demand curve. It's not a market graph. Now, supply is our next item here. Okay, excuse me. I don't know what's going on with this PowerPoint. Okay, there we go. Sorry, this thing got stick. Supply is the other side of the market. It's the force we associate with the producers and sellers of a product. Supply is also a schedule, a relationship between two things, in this case, price and quantity supplied. A schedule that shows, all else being equal, various quantities of a good or a service that producers, businesses that make and sell, are both willing and able to make and sell in the market over sets of prices that might be charged during a given span of time. Now, of course, I always have one student who means well and says, well, don't some producers try to sell more at a lower price? Those producers know their demand. Do you see a demand curve in this graph? No, you don't. If producers don't have any knowledge of demand, in general, they'd rather sell more at a higher price and less at a lower price without having information about the demand curve, which is why the supply curve, as you see here, is represented as a positively sloped line. Again, this is consumable goods and services. Same axes, dollars, prices are measured in dollars and cents, and quantity measured in units. And we also only have the first quadrant of the Cartesian plane. Class, I didn't mention this earlier, but the reason why it's first quadrant is because prices cannot have negative dollar values. Prices can change negatively, like the price could drop from $2 to $1.50, but they can't be equal to negative 50 cents. That's not possible. Negative change is allowed, negative values not allowed. And for those who've worked retail, every now and again there's a computer hiccup where it assigns a negative price. That's just what it is, a mistake. Either something is air quotes free, meaning the end user doesn't pay for it, it still costs them to provide, or it's a positive price that is paid for it. And quantity can't have negative unit values. It can decrease. A business can produce and sell 50 less units, but it cannot make negative 50 units. What are they made from? Antimatter? I don't know. But the law of supply states we have a positive or direct relationship between the price charged for a product and the quantity supplied of the product. And as I said before, without knowledge of the market demand, businesses will try to produce and sell more at a higher price. They'll try to produce and sell less at a lower price. Now, this is also not a market demand. Markets need both supply and demand to be a market. And so, boom, there's your market graph. A market graph has a supply curve. A market graph has a demand curve. And if there's an intersection where the price and quantity are not negative, the market has a valid equilibrium point. Equilibrium is visually the intersection of the supply and the demand curves, and it's defined as the point in the market at which there exists some price. Price P star is a special price. P by itself is the variable price, but P star means equilibrium price. At this price P star, the quantity that consumers want to buy and consume at P star is equal to the quantity that businesses want to make and sell at P star, which we will call Q star, which stands for equilibrium quantity. Now, markets don't start off at equilibrium. You've probably noticed that every time Microsoft or Sony releases a new product, they don't sell as much as they have on the shelves because some people are waiting to see what happens. Some people are waiting to see if the new update is good or not. And so what starts to happen over time, though, is since that market's not in equilibrium, since they're producing too much and the price is too high, businesses will start lowering prices and producing less, while at the same time as the price drops, people start buying more, and then the market eventually adjusts to equilibrium. That's the old invisible hand guiding the market to its perfect conclusion. There are other times where products are released, like those Snackwell's cookie cakes and like the original Nintendo Wii, where they undercharge the market. Businesses can't produce and sell as much if the price is below equilibrium and the product flies off the shelf. And what starts to happen is consumers start saying, "Take my money, man. I'll pay $50 more if you can get me one of those." And eventually the sellers start raising price. And as they get more money, they start making more product. But at the same time, as the price starts going up, some people say, I don't want it as much. And again, as long as no outside forces preventing the market from doing so, it will clear to an equilibrium. Now, we're working today with how do you get a math formula using numbers that represents the market demand and supply, and how do you use a math formula to solve for the equilibrium price in dollars and cents and the equilibrium quantity in units. And so we're applying some algebra that you would have learned in maybe middle school, high school, or even in college, and we're going to be using linear equations. However, we will not use y equals mx plus b. This is not Algebra 2301, this is ECON 2301. And so you will use economic symbols for economic formulas. Y stands for, in economics, the domestic parts of gross domestic product, consumer and gross private investment and government spending. It can't be used for price. Only P is used for price. And similarly, X stands for export spending, one of the two foreign parts of GDP, and cannot represent quantity. Only Q represents quantity. Also, you will notice in the problems that we have about this, prices are stated in dollars and cents, and you will state them in all declarative statements in dollars and cents. And the dollar sign goes on the left because this is not Quebec. Quantity is stated in declarative statements in units as well. And so we're going to go over here and take a look at some of the practice problems here. For the 2302 class, the very first three problems that are in there are all supply and demand curve math problems here, and they also include a part D that is not in the macro class. Similarly, in the macro 2301 problems here, the first three problems are also the same three math problems where we've got demand supply schedules. It's just that they don't have the part D. And so what we're going to be doing here in this video is we're going to work problem number 1 on both of these. And as we do, I'm going to introduce the formulas. Now let me go over here to this formula sheet that is for the 2302 people here, but I want to zoom in a bit. We're going to talk about these formulas here. First things first, when you're dealing with a straight line equation, you have to have something called the slope. Slope is equal to the vertical change divided by the horizontal change. Since price is the vertical variable, we have delta P. That triangle is the Greek letter delta, which means change in, and in math, the change means as a difference, there's subtraction. And then delta Q, change in quantity. If it's from the demand schedule, it's quantity demanded. If it's from the supply schedule, it's quantity supplied. Now, these little numbers you see down here are called subscripts. If you see P by itself, that's price as a general variable. If you see a P sub 2, that is a specific known price, a certain number of dollars and cents. And I always say, since we're working with tables, P2 is the price in the second row, P1 is the price in the first row, with the understanding that top row is first, bottom row is second. Now you'll notice Q2 minus Q1 is in the denominator, and these have the same subscript because they're from the same row. You cannot mix and match prices within the same table or across tables. You cannot crisscross applesauce. Second price minus first price up top, second quantity minus first quantity down below. And notice we have a major division bar. Some of y'all may remember the expression PEMDAS, or please excuse my dear Aunt Sally. If we have something in parentheses, it's evaluated first. When there's a major division bar, you treat the above and below the major division parts as if they were in parentheses. And so what that means for y'all is what we're going to be working over here for this problem is you have to treat the top and the bottom as if they're in parentheses. Multiplication, division are second order operations after parentheses, and then addition, subtraction are the lower order unless, of course, they are in parentheses, which they are. So I've copied problem number 1 over here, and one of the things that I always like to do when I'm working this stuff here, you would be doing this by hand, obviously. I'm using formulas so it's easier to read for everybody, is I always copy the formula first. I'm using math type here, or equation 3.0. I like to use it because it's convenient to use. Now, calculate the slope of demand here for part A. Part A says to do 3 things: calculate the slope of the demand curve, interpret it, and calculate an equation representing the demand curve. So we're going to do that here. And so please don't mind me while I'm typing this stuff in place here. Just try to follow along. The second price in the demand schedule for problem 1 is $58, but we're not going to put the dollars and cents in the arithmetic because that's cumbersome. This is not a declarative statement. This is a math calculation. We'll show you where that shows up in a minute. And the first price is $73, so I have 58 minus 73 up top. And then the denominator, I've got the second quantity of 80 units, so we just put 80, and then minus 50 units down below. And so that's your first step. You plug the numbers in the formula, and everybody needs to take 2 or 3 steps here. Do not try to combine too many steps, especially if your math is rusty. You want to go slowly. So now we have to do those subtractions first. And so I've got my equal sign here. 58 minus 73 is not 15. When you subtract a larger number from a smaller number, the result is negative. 58 minus 73 is negative 15. And then 80 minus 50 is 30. Now, nope, 90? No, it's 30. Now, next step here is I like to bring the minus sign out to the front because whatever this fraction is going to be, it's clearly negative. And for demand, it has to be negative. But we are not, everybody listen up, not using decimals. 30 and 15 have a common factor, and that's 15. And so if I factor 15 out of the top, I'm left with a 1. And if I factor 15 out of the bottom, I'm left with a 2. And so the slope of that demand curve is equal to negative 1/2. Do not use negative 0.50 because we will not use decimals for slopes that are not whole numbers. Now, I do recognize that negative 0.5 equals negative 1/2, but what if been negative 1/3? Negative 0.33 does not equal negative 1/3. It would be negative 0.3333333333, and it goes on forever. And so to avoid rounding error, we have to write it as negative 1/3. So everybody, please be good. Please follow your instructor's directions. Please don't use fractions. Now, let's see here. I forgot to put we're working part A, and so let me put that over up front. Let's talk about interpreting now. And interpretation means to write an English sentence that explains what is going on here. Now remember, the numerator is the change in the price. So that's a $1.00 change in the price. I'm going to start writing a $1.00. And I'll pause for a second. Price can only change two ways. It can increase or it can decrease. Now, since before I simplified that fraction, the negative was up top and negative change suggests decrease, I'm going to write a $1.00 decrease in the price. Now, I'm starting with price because the cause and effect chain matters. When you have a change in the amount of a product people want to buy, usually what happens is the price changes first and people change the amount they want to buy in response to it. The price always changes first and the quantities demanded or quantities supplied will change second. So a $1.00 decrease in the price causes a 2 unit. I'm getting 2 from the denominator. I'm getting unit because quantity is measured in units. This is where we do our formatting here. But if the numerator is negative, for a negative fraction, the denominator has to be positive. I'm going to say a rise in the quantity demanded. Now that Q with a D on it, and I always like to make that a superscript here, okay, because that's just the way we always like to show it here. And of course, I'm getting a slow response from Word here. Please forgive me. Make that a superscript there, okay. And that's not what I wanted to make a superscript here. Whoopsie. Let's go back over to the right document. Folks, I appreciate everybody's patience over here, by the way. This is just something that's kind of par for the course. This here is one valid interpretation for the slope of demand. Now, the thing is, prices don't just decrease, they also increase as well. And so as a result of this, an equally correct statement would have been a $1.00 increase in the price causes a 2 unit decrease. Now, okay, now I wrote rise. I usually like to say rise here in quantity demanded. Okay. And so let me do one other thing here, folks. And again, I appreciate everybody's patience as I'm kind of doing this on the fly here. I'm going to go to narrow margins so we can space this out a little better. Okay, bueno. All righty. So there we have it, folks. That there is our slope of demand here in the interpretations. And boom, boom. Okay. Now, we've got the slope of demand. We've got the interpretation here. The next step, it says, is to calculate the equation that represents the demand curve. But to get the equation, we need another piece of information here. I'm going back to the formula sheet now. We need to get the formula for something that is called the vertical intercept, which is shown right here. The vertical intercept has the symbol K. K means a constant in math speak. It says K is equal to P0 minus M times Q0. And so what it is this here. You're going to take M, okay, that you calculated up here, the -1/2, and you replace the M with the -1/2. But the P0 and Q0, we'll say there's no 0 row in the table. When you see the number 0 as a subscript, it means choose whichever row you wish to use, but you have to use the price and quantity from the same row. So I'm going to go back over here, and I'm going to choose $58. I'm going to start by putting down the formula first here. You should always put down the formula first because that makes it easier to work with. And then I need to go ahead and use my math, my equation 3.0, because that's just what I'm comfortable using here. And so, no, I don't want to learn about math type. Please stop showing me this here. I am going to make sure I got my minus sign. I'm going to make sure that I got my top and bottom here, 1/2, and then I'm done with that. So that's equal to -1/2, and that's going to be, wait a minute, I forgot with P. I got to start with P first. Bad professor. Okay, sorry about that, folks. This is easily fixed. I'm replacing P0 with 58. And then I put my parentheses, and I've got a minus here. I'm going to put my parentheses there. And then -1/2, and then we have a multiplication symbol. And then the units associated with $58 is 80 units. Again, we don't put the units and the dollars in the arithmetic because that's going to make this cumbersome. Now, PEMDAS, we have to do what's inside the parentheses first. So the 58 stays and the minus stays. Okay. Now, half of 80 is 40, but wait just a second, y'all. -1/2 times 80. Remember, if you multiply or divide opposite signs, the result is always minus. That's going to become -40. Okay. Now, so far we have solving for the vertical intercept. We've got 58 minus -40. Now let's talk about the next thing. Whenever you subtract a negative number, you have to clear the minus through there, as some professors say. Subtraction is defined as you have two numbers, You change the sign of the number that is being subtracted. So I change this minus to a plus, and I change the operation to addition. So that becomes 58 plus 40 by the rules of subtraction as defined by algebra, and that's going to equal to 98. So the vertical intercept is equal to 98. Now, we're still not done. Let's talk about the equation representing demand here. All demand equations take the format of P is equal to M times Q plus K. But what you do is you take the results of M and K and plug them into there. So I'm going to copy this and paste this over into the document we're working here. And again, thank you for everybody's patience as I go through these mechanics here. Equals M times Q plus K. The rule states here, okay, first of all, I need this minus 1/2. I'm going to replace the M with minus 1/2 here. And so paste that. And the K was 98. Okay. So I've got that in there. And let me just tab over here. The demand equation starts from P equals and ends with a 98. Everything you see there, I'm going to highlight this for y'all. P is equal to negative 1/2 times Q plus 98 is the equation that represents the demand curve. So what we have done here, folks, is we have first of all calculated the slope of the demand curve. The slope of the demand curve is equal to negative 1/2. We then interpreted it. We wrote a $1.00 decrease in the price causes a 2-unit increase in the quantity demanded. We then calculated the vertical intercept as 98, and then we declared the equation that represents the demand curve. P is equal to negative 1/2 times Q plus 98. So now we're done with part A. Now part B says, remember what we just did for part A? Okay, let's go ahead and do that, but this time we're going to do it for supply. Okay, so I'm not going to reinvent the wheel here. I'm just going to borrow this, but I'm going to go ahead and I'm going to copy and paste that, but I'll make some changes, and that's not what I wanted. Excuse me, y'all. Okay, so copy, and then paste here. Just paste. But then I need to delete all this stuff here. It's after this. This stuff here is no longer valid. So you notice I've got that supply schedule up there. Okay, I've got the supply schedule up there. I have to start by replacing the 58 minus 73 with the prices in the supply schedule. So that's going to be 68. And then 73, I got to replace with the 128. Notice we're using stuff from the supply schedule here. And then for the denominator, I have to have 130 minus 150. Now, 68 minus 28 is equal to negative 60. And then 130 minus 150 is equal to negative 20. Now, remember what happens when you divide two negatives. If you divide or multiply the same sign, like if both numbers are negative, the result is positive. And 60 and 20 divide evenly into each other, so we put that as positive 3, and that's all we write. Okay, so the slope of the supply curve has to be positive, and it is. It's positive 3. We do not write 3 over 1. When you have a whole integer, if it's negative 5, you just write negative 5. You don't write negative 5 over 1. If it's a positive 3, you just write positive 3. You don't write 3 over 1. Now, to get to the interpretation here, we do understand that there's an invisible denominator of 1. The delta P is the $3, so I start with a $3, and 0 cent change in the price. And since we have a positive 3, that suggests an increase, positive change. The $3.00 increase in the price is causing a 1 unit. Remember, all whole integers have an invisible denominator of 1. Wait a minute. If 3 is positive, the 1 is positive. That means if price is increasing $3, that means quantity supplied is also increasing. So a $3.00 increase in the price causes a 1 unit increase in the quantity. Wait. See this little thing up here? That's not a QD. This is not the demand schedule. This is the supply schedule. So we're going to say it causes a 1 unit increase in the quantity supplied. It has to be quantity supplied because this is related to the supply schedule. This is not the demand schedule. This is the supply schedule. And I'm waiting on this thing to do something here. And it's not doing it, so, and waiting. This is the reason why I prefer to use a wipe-off board, but unfortunately, it doesn't work too well when I'm doing this with my laptop PC. So let's see here. Maybe it's popping up somewhere else. Cancel. Okay. You know what? Don't reinvent the wheel. I'm going to copy what I already got. Again, I prefer the wipe-off board for this reason alone. I don't have to deal with this nonsense there. A $3.00 increase in the price causes a 1 unit increase in quantity supplied. Yay. It would be equally correct to say a $3.00 decrease in the price causes a 1 unit decrease in quantity supplied, but notice, direct relationship. The two variables have to change the same direction. Notice it's QS, not QD. Watch out, those are some common mistakes. Alrighty then. Now, I need to solve for the vertical intercept, which is called K. So we're going to solve for that. K equals, okay. And then I'm going to replace P0 with one of the two prices here. And to me, it seems easier to use $128. If you want to use $68, knock yourself out. Minus, and then 3 is a slope, so we replace the M with a 3. And then the quantity associated with $128 is 150 units. Now you could have wrote K is equal to 68 minus 3 times 130. You're going to get the same result either way. This is a case where probably a calculator might be warranted. However, I know that 3 times 15 is 45, so 3 times 150 has to be 450. And so we've got 128 minus 450. Now, since I'm subtracting a bigger number from a smaller number, the result is negative. 450 minus 128, well, that is equal to 322. So 128 minus 450 has to be negative 322. Ta-da! Now, last but not least, we have to declare the supply equation. So I'm tabbing it over here to keep it in a similar spot here. The supply equation, P, is equal to 3 times Q minus 322. Now, class, it is perfectly possible to have a negative vertical intercept for supply. Only the part that is in the first quadrant is going to be used, but the negative vertical intercept will work because that's the way the supply schedule is going to work. You know, to start producing, price typically has to be above a certain level, and they have to produce a certain number of units to make it worth their while. So we have done everything that was asked for in Part A for the supply curve using the supply schedule. We calculated the slope of supply to be equal to positive 3. We interpreted it by saying a $3 increase in price causes a 1 unit increase in quantity supplied. You could have said decrease and decrease. We calculated the vertical intercept to be negative 322. And we declared the supply equation to be P is equal to 3 times Q minus 322. So we are doing well. Now for Part C. Part C means we have to solve for the exact point that is equilibrium. Let's go back over here. There is going to be a Q star that we will solve for first, and we have to state how many units it is. And there will be a P star we solve for second, and we have to state how many dollars and cents it is. And this is accomplished by setting the supply curve equal the demand curve and solving for Q star first. But then we substitute Q star into one of the equations and then solve for P star. All right. So let's go ahead and go back to the document here, and we're going to set this up. And that's the wrong document. Excuse me. That's why the formula's there. Okay. So both of these say P equals and P equals. So what I'm going to do is I'm going to borrow the equation over here first for the. Actually, I'm going to do the supply one first. I'm going to start by writing 3Q minus 322 is equal to, and I'm going to copy this and I'm going to remove the highlighting here from this. Control C, Control V, and then no highlighting. And done. Okay. So what I'm doing over here, let me scroll up here and zoom in on this here, is I've set the supply equation equal to demand equation. Now, some people see the fraction, they start going like they freak out. Their brain has a total short circuit. They say, "You're Professor Lewis, I drove here on the short bus. I don't like to work with fractions. Is there a way we can get rid of them?" Yeah. If I were to multiply all 4 terms, and it has to be all 4 by the number 2 for this equation, I won't have fractions anymore, but the numbers get bigger. So I'm going to do this for the sake of the people who have fraction problems. But for those of you who want to change this 3Q to 6 times Q over 2, knock yourself out. I'm trying to do this for the folks that struggle a little bit to try to minimize the struggle. So 2 times 3 times Q equals 6 times Q. And that's the wrong button there. 2 times minus 322 is minus 644. Equal sign remains an equal. 2 times negative 1/2 is just negative 1, and that's times Q. And then 2 times 98 is equal to 196, and that's positive. And so by multiplying all 4 terms by 2, I've got rid of the fractions. Now the next step we have to do is we have to group our like terms, and this is accomplished by adding and subtracting from both sides. And so the thing is, I always start with the variables. If I were to add q to the right-hand side and also to the left-hand side, I'd get my q's all together. So what I'm going to do here, I'm just going to put plus q for now. And if I go over here, I'm going to put a plus q. I'm going to have to put something else in just a second here. So if I add these q and q, these will basically add up to 0. They will cancel out, as some people like to say, but I'm not too fond of that term because cancel out suggests it disappears for no reason. This thing is not disappearing for no reason. What's happening here is very simple. Okay, well, let me do a strike through here. Yes, it will. So boom, and then boom. Okay, those are canceled out once I get this thing in here. So boom and boom. Okay, now the thing is I also have to do something else. I need to add 644 left and right in order to group the two constants together on the other side of the equal sign. Because if I don't do that, the equation's value is changed, and that's a big time no-no here. I want to make sure we don't do a no-no. So if I add 644 to the left, I have to also add 644 to the right, and this thing should not be struck through. Okay, so again, bear with me while I'm dealing with this thing here. Prove that. Okay. The thing is, this will be struck through because a minus 644 plus the 644, those will zero out. So I'll strike through each of them individually as they zero out. And then pardon me while I deal with this stuff here. This will give you a chance to write and catch up with what's going on here. Bum, 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 bum. Strike through. And it doesn't have to go all the way over to there. All right, so let's go to the next line here. 6 times q plus 1 times q is equal to 7 times q. And then equals 196 plus 644 is equal to 840. Now this is closer to what we want, but we want this thing to say q star equals. We need this thing to say q star equals. And so the question is, well, how do you do that? Well, the way you do that is you divide both sides by 7. 7 times q divided by 7 will just be 1 times q, and that's q star. I remember 7 times 12 is 84, so 7 times 120 has to be 840, but then we put the word units because this is our final answer. The equilibrium quantity says Q star is equal to 120 units, but we're not done. The next thing we have to do is solve for P star because we got to find how many dollars and cents that is. And remember these two equations we had. P equals. We use those to solve for equilibrium price, and I expect y'all to use both of them because you want to make sure it's correct. So I'm going to start by writing P equals. I'm going to replace the Q with 120. That's how many units Q star is equal to, and then minus 322. I'm using the supply equation first because it's easier thanks to the fact that it has a whole number for its slope. Now 3 times 120 is 360, excuse me, and then minus 322. 360 minus 322 is going to equal to 38, but wait a minute, this is a price, it's dollars and cents. So that's what P star is equal to based upon the supply equation. Well, I'm going to use the demand equation next here, so give me one moment, please. I'm going to borrow something to avoid having to redo the math type part. P star using demand, okay? I'm going to rotate the 1/2, and then I'm going to replace the Q with 120. And I'm going to put this in parentheses because you have to multiply the negative 1/2 times the 120 first. And then plus 98. Now, half of 120 is 60. So negative 1/2 times 120 should be negative 60. Negative 60 plus 98. Negative 60 plus 98 is the same as 98 minus 60. And that is also equal to $38.00. Excuse me, let me put that equal sign in there. Head professor, need to have that in there. Notice we got the same price from both equations, and so we are confident it's correct. Notice the quantity, Q star, was not a weird decimal or fraction. It was an even number of units. My problems are designed to work this way. Notice the price was a nice dollars and cents. It didn't have a long string of decimals. Notice the values are positive. They cannot be negative. If you get a weird long string of decimals, or if you get negative values for P star and Q star, that tells you made a mistake somewhere. You need to back the truck up and see where that was. Now, hold on one second, please.